AI, the present and future. Agent components. Interaction with the environment through sensors and actuators. For much history of AI, this has been a glaring weak point. AI systems were built in such a way that humans had to supply the inputs and interpret the outputs, while robotic systems focus on low-level tasks in which high-level reasoning and planning were largely absent. This was due in part to the great expense and engineering effort is required to get real robots to work at all. This situation has changed rapidly in recent years with the availability of ready-made programmable robots. Keeping track of the state of the world. This is one of the care capabilities required for an intelligent agent. It requires both perception and updating of internal representations. Projecting, evaluating, and selecting future courses of action. The basic knowledge representation requirements are the same as for keeping track of the world. Learning. Chapter 18 to 21 describe how learning in an agent can be formulated as inductive learning, supervised, unsupervised, or reinforcement-based of the functions that constitute the various components of the agent. Very powerful logical and statistical techniques have been developed that can cope with quite large problems, reaching or exceeding human capabilities in many tasks, as long as we are dealing with a predefined vocabulary of features and concepts. Hybrid architecture defines as hybrid all architectural intervention that is at once object, landscape, and infrastructure. One important property of hybrid architectures is that the boundaries between different decision components are not fixed. For example, compilation continually converts declarative information at the deliberative level into more efficient representations, eventually reaching the reflex level. Agents also need ways to control their own deliberations. They must be able to cease deliberating when action is demanded, and they must be able to use the time available for deliberation to execute the most profitable computations. For example, a taxi driving agent that sees an accident ahead must decide in a split second either to brake or to take evasive action. It should also spend that split second thinking about the most important questions, such as whether the lanes to the left and right are clear, and whether there is a large truck close behind, rather than worrying about wear and tear on the tires or where to pick up the next passenger. These issues are usually studied under the heading of real-time AI. General methods of controlling deliberation. 1. Anytime algorithm. An anytime algorithm is an algorithm whose output quality improves gradually over time, so that it has a reasonable decision ready whenever it is interrupted. Example of an anytime algorithms include iterative deepening in game tree search and MCMC and Bayesian networks. 2. Decision theoretic meta-reasoning applies the theory of information value to the selection of individual computations. Meta-reasoning techniques can be used to design better search algo and to guarantee that the algo have the anytime property. Meta-reasoning is one specific example of a reflective architecture, thus is an architecture that enables deliberation about the computational entities and actions occurring with the architecture itself.
Created using Powtoon.